Hey there, and welcome. So, when I say black hole, what do you picture? Probably that classic image, right? A kind of cosmic vacuum cleaner, a super mysterious empty hole in space. But what if that picture, the one we all have in our heads, is just, well, a fairy tale? Today, we're going to dive into a radical new idea that flips everything we thought we knew about them on its head.
So, here it is, the big question we're tackling. What if black holes aren't empty at all? What if instead of being nothing, they're actually the most complex somethings in the entire universe? I mean, just that one question, it challenges decades of physics and opens up a whole new way of looking at the cosmos.
Okay, so before we can get to the new stuff, we've got to talk about the black hole we all know and love. You know, the one from the textbooks. This is that traditional mathematical version, a concept that's been super useful for sure, but it might not be the whole story. Right, so the classic model is honestly, elegantly simple. There's this idea that it has no hair, which is just a physicist's way of saying it's completely featureless. No lumps, no bumps. All of its mass is supposedly crushed into this infinitely tiny point in the center, called a singularity. And get this, all the information about everything that ever fell in, it's somehow stored on its two-dimensional surface, the event horizon. And you can't even check. If you try to poke it or shoot energy at it to see what's inside, you learn nothing, you just make the black hole bigger.
And you know, the source material has this fantastic way of putting it, comparing the whole idea to alchemy. It's like saying, yeah, the math works out on paper, but this concept of a featureless void with information just painted on the outside, it might be more of a convenient story than what's physically real.
So if the old model is a kind of fairy tale, what's the real deal? Okay, this is where it gets really exciting. Instead of a simple void, we're going to take that old idea and embed it into something totally new, a black hole with real, actual physical substance.
And this chart just lays it out perfectly. The difference is night and day. We are moving from a featureless void to an object that has the most complex structure you can possibly imagine. Information isn't just sitting on a 2D surface anymore. It's literally woven into a three-dimensional fabric. We're treating a mathematical fairy tale for a realistic physical thing. Which, of course, brings us to the biggest question of all. If a black hole isn't an empty point, then what in the world is it made of? What is this fabric that's holding all that incredible complexity? So here's the new definition. A black hole is an object that packs the absolute maximum amount of mass and the most complex structure possible into any given volume of space. It's not empty, it's literally the fullest thing imaginable. Okay, this is the crucial part. This new kind of black hole is made of a tangible fabric of spacetime. It has a real shape, a real structure. And information isn't just written on it like a name tag. It's part of the very shape of the fabric itself. So when something falls in, the fabric reshapes, and the information is now stored implicitly in that brand new shape. And if you're trying to picture this, the source has this incredible poetic way of putting it. It suggests calling this internal structure white noise. Just imagine a chaotic, churning, unbelievably dense tapestry of every possible frequency and shape, all woven together at once. That's the inside of this new black hole. But, and this is a really important detail, it's not infinite chaos. Because the black hole has a finite size, right? A finite volume. That physical boundary actually puts a limit on the kinds of frequencies that can exist inside. It's as complex as it can possibly be, but it's not infinitely random. It's chaos with rules. Okay, so you might be thinking, this is cool, but what's the point? What does this new model actually do for us? Well, it helps solve one of the biggest headaches in all of physics, the black hole information paradox. And we're going to explore it with a simple example. Let's call it the wallet paradox. So here's the paradox. A fundamental rule of physics says information can never, ever be destroyed. But if you drop your wallet into a classic black hole, it seems like it just vanishes from the universe. The shape of the wallet, the leather it's made of, the data on your credit cards, is all of that just gone? The old model really struggled to answer this. But in our new model, the wallet's journey is totally different. See, your wallet isn't just an object, it has a unique shape in the fabric of space-time. When it falls into the black hole, its shape doesn't just disappear. Instead, it merges with and becomes a part of the black hole's own incredibly complex internal fabric. The information isn't destroyed, it's just transformed, woven into the chaos. It's still there. And this really gets at something pretty profound. We humans, we use the word information as a tool to describe the universe. But the source suggests that the underlying reality is just the machinery of nature doing its thing. The fabric of space-time is constantly reshaping itself, and what we call information is just our human way of describing that physical process.
So why does all of this matter? This isn't just about trading one abstract physics model for another. This new perspective on black holes could fundamentally change how we think about the structure of reality itself. The whole point here isn't to just say, the old theory is wrong, throw it out. It's about getting a much more complete and physically real understanding of these amazing objects. It's like moving from a quick pencil sketch to a detailed, full-color portrait of reality. And this quote just nails it. This is the perfect analogy. We still use Newton's laws of gravity all the time. They're great for sending rockets to the moon. But we know that Einstein's general relativity gives us a deeper, more accurate picture of how gravity really works. This new black hole model is trying to do the exact same thing for black holes. And that's really the key takeaway here. The fairy tale black hole isn't necessarily wrong. It's an incredibly useful simplification. But the fabric black hole, that offers us a glimpse into a more complete and honestly a way more fascinating reality. There's room for both of these stories in science. So I'll leave you with this final kind of mind-bending question. We used to think of black holes as these points of ultimate simplicity, of nothingness. But if they're actually objects of maximum complexity, the absolute fullest things in the universe, what does that imply about the fundamental nature of reality itself? It suggests the cosmos might be far more intricate, far more full of substance than we ever dared to imagine.